Okay, we now move on to parallel lines and perpendicular lines. Okay, I don't know if you remember from last year, but for parallel lines, if we have two lines like that, we know that their gradients are. So if this is M1 and this is M2, we know that the gradients of parallel lines are equal. So I guess this is the rule you need to know. Okay, then when we think about perpendicular lines, so let's say I have the x and the y axis, okay, and I have a line going this way, and this is the gradient M1, and then I have a line coming across this way, and this is has a gradient of 2. We can show that these two lines are perpendicular if we can show that M1 times M2 is equal to -1. Okay, and of course this can be rearranged. M1 is equal to -1 over M2, or M2 is equal to -1 over M1. So you can rearrange that, but this is obviously the best result to start with. Okay, so if I was to look for an example here, what is the gradient of the line parallel to 3x minus 2y plus 6 equals 0, okay, I would first of all rearrange that into y equals mx plus b. So then I would have, so take the 2y to the other side. So I end up with 3x plus 6 is equal to 2y, and I divide every term by 2. So I end up with y is equal to 3 on 2x plus 3. Okay, well, can you now tell me what the gradient of this line is? That's the gradient, okay, of that line. So the gradient parallel to this line would be exactly the same. So therefore, M2, which is the gradient parallel to this line, would be also equal to 3 on 2. And that's all you have to do. So the whole idea here is to identify the gradient, and then any line parallel to that line will have the same gradient. Okay, perpendicular lines. Let's just have a look at a question. Okay, so let's look at this, an example. The interval joining the point okay, C, which is -6, 0, and D, which has coordinates -1a, okay, is perpendicular to the line with gradient 10. So you guess what the question is going to ask you to do, right? What is the value of A? Okay. All right, so let's have a look and see what this is actually asking us to do. I'm going to quickly sketch what we have here so you can see and it makes sense to you what the question is asking. So let's just have a look. All right, so let's just, all right, point C is -6, 0. There's C. Okay, and D is -1. So it's somewhere over here. I don't need that much over here. -1a. And We don't know if it's a positive A or negative A yet, but we'll see. Okay, it could be here, it could be somewhere over here. So this is what we're looking at, the value that's missing. All right. Now this interval is perpendicular to the line with a gradient of 10. So if I have a line, so if this was a point D here, and I draw a line going that way, so this interval, and this is negative 1A, let's just say that that's what I'm doing. I've been told there's a line perpendicular to this, so we draw another line going this way with a gradient of 10. Okay, so how is this information going to help me? Well, what we should be able to find is, first of all, the gradient of CD. So let's do that in terms of A. So find the gradient of CD. Y2, so A minus 0 all over negative 1 minus 6. So I end up with A over, well, that's negative 1 plus 6, so that's A on 5. That's the gradient of CD. Now, we're told that this line is perpendicular to the other gradient. So I know, let's call this M1. And M2 is your negative 10, right? Sorry, your 10, this one. Okay, and I've drawn this the wrong way because it's a positive 10. So that's, if you think about it, the line perpendicular should be going the other way. So obviously A is going to be down here somewhere. Let's have a look and see. Okay, it's going to make more sense once I get it all done. So using the rule, M1 times M2 is equal to 10. All right, I end up with A on 5 times 10 is equal to negative 1. So now I have an equation, and this is easy to solve. 5 into 10 goes twice, so I end at 2A is equal to negative 1, divide by 2, therefore A equals negative a half. Okay, so the line that I'm looking for, D, is actually down here. So here's my C, D is negative 1, negative a half. So this is my line, and I should have seen that before because it was a positive 10. I don't know why I thought it was negative 10. Okay, so this is the interval CD. All right, I found the value of A, and the line perpendicular to this one had a gradient of 10, and that was your perpendicular to that, so it was the other way. So there you go. Sometimes looking at diagrams, it just helps you realize and think what's going on. Okay, so that's perpendicular lines and parallel lines. All right, now you should be able to do exercise 6B. If you have any questions, send them to us. Look at the slides, and the typical questions here is like, show that these vertices, or you're given points A, B, C, and D form a parallelogram. Well, what do we know about a parallelogram? Opposite sides are parallel, so that means that you have to use the gradient and show that the gradients of the opposite sides are the same. All right. Then what's another type of question that you could get with I'm just trying to think. The diagonals of a rhombus are perpendicular. Well, that means that you still need to look at the gradients of the two diagonals. So look at the vertices, find those gradients, and show that M1 times M2 equals negative 1, and you'll be able to show that the two lines are perpendicular, and so on. They're the type of questions that you need to be thinking about. Okay, and I'll stop that there and hope you don't have too many issues with these questions. But if you do, Send us a message.